We have created super intelligent systems that are better than people at certain tasks. We don't understand how they work. What decisions are being programmed into these systems? I believe these are very important issues that society needs to be talking about now before we release these artificial intelligences in the wild. The Rational View is a weekly series hosted by me, Dr. Alan Scott, providing a rational, evidence-based perspective addressing important societal issues. Hello and welcome to The Rational View. I'm your host, Dr. Al Scott. On this episode, Artificial Intelligence, the Promise and the Risk. And by the way, Happy New Year. Good riddance 2020. We all have 2020 hindsight now, and that's a good thing. Let's hope this year is a little better. I hope you're all staying safe and not spreading the virus. So, as I discussed at the end of last year on my gun control episodes, I've decided to turn over a new leaf in terms of how I approach my podcasts. My overall concept is to still show the scientific method, but to do it in a progressive way so that you can follow my thinking and my methods and follow how I learn about a topic. So in this case, I'm going to be talking about artificial intelligence. I'm not an expert on this. I don't know a whole lot. I think maybe it's going to be easier for people to follow along if we all start at kind of a low level instead of me just throwing dense facts at you from episode to episode. This week, we're going to start at a low level, and over the next few weeks, we're going to work up and see if we can understand more on artificial intelligence as we progress through a few episodes. So I think this hopefully will provide an easier path for people to follow along. It's also a bit of a challenge for me to come out to you and present my ignorance at the outset. I like to give you useful facts, and I hope you will learn something. And so if I make mistakes, hopefully we can correct them in further episodes. So it's a bit of a challenge for me. In this episode, I've refrained from researching anything at all. And mainly what I'm going to present is what I can remember from previous reading I've done. Now, this is a topic that I have some knowledge of. I've had an interest in artificial intelligence. I've followed the research. I'm going to do my best to present my initial understanding, and then we're going to work forward through this and get at the benefits and the risks, because there are risks to artificial intelligence. And if you're just new to the program, thank you for tuning in. Please share with your friends and send me a comment. Let me know if you like my episodes. And also, please feel free to send me any suggestions onto my Facebook page at Al Scott Rational. Let me know what you want to hear in future episodes. So for this episode, what is artificial intelligence? You've probably all heard the term. So artificial intelligence is a form of software program. It's a computer software and a bunch of algorithms that can do tasks that are normally associated with humans, thus the artificial intelligence. Things like image recognition, playing chess, doing medical diagnoses, driving cars. Now, how can computers do this? Computers aren't intelligent, self-aware beings. Well, I'll get into what I understand is driving the field of artificial intelligence. But this has been foreseen for a long time in the field of software. In fact, Alan Turing promoted a test for artificial intelligence. He foresaw the point where computers could potentially appear intelligent. And his test was, can an external person tell it is talking to a computer if their interactions are with a black box and either there's a person behind with a microphone or it's a computer interacting with them? Can they tell the difference? And this is the Turing test for intelligence. And you could tell that in early applications of artificial intelligence, it was pretty obvious that you were talking to a computer. I remember playing with Eliza, which was available online back in the 90s. It was a chat bot. It would echo back questions to you, and supposed to be a psychotherapy device. And you would ask it a question, it would ask you back, why do you think this? Why are you so concerned about these things? And often it didn't make a lot of sense, and it couldn't answer out-of-the-box questions. Other examples that I'm aware of artificial intelligence is the 20 questions game. Now, someone has trained an artificial intelligence to play 20 questions. I remember contributing to the beta version when it was online back in the 90s. You could go and play 20 questions with it, and it wasn't that great, but it got better. It actually learned how to play 20 questions, and now you can buy this system. All the training has been put into a tiny little chip, and you can buy a box that'll play 20 questions against you, and it usually wins. And these are examples of the advance of artificial intelligence, how it's gone from something very simple to something very complex. And in the past, where it was laughably simple, now these things are smarter than most people in the tasks that they do. A lot of these are targeted applications. So each one is not generally intelligent, but it's targeted at an application. And this is something called an expert system. And these expert systems include Scrabble bots, chess bots, and they're programmed with various levels of strategy of the thing that they're trying to do, of the task they're trying to do. They're given a set of expert level strategies that help them limit the analysis of potential outcomes. Because in any sort of programming thing, you don't want the computer to investigate all of the options and just churn through all of them. It just takes forever. This is exponential time, it's called. If you have a bunch of large choices with a lot of things you can do, to track down all of them in just a brute force and ignorance type of way takes an exponential amount of time. In other words, you'll never get it done on a computer. The computer will just bog down trying to look at all the possibilities and figure out what's the best move. Computers aren't doing that. When you're coming up against a computer in a suitably complex interaction or simulation or game, it's not looking at all of the options. If it is, it's only looking a couple moves out, say, in, for example, chess. It can only look a few moves out before it runs out of time. But if you use the expert system programming, you can prune off the less useful moves based on some rules of thumb, for example, that experts program into it. I remember back in the day, scientists had said that artificial intelligence could never outperform people on certain tasks. That you just couldn't be smarter than people. We had that sort of confidence, that hubris. I remember the day when IBM's Deep Blue supercomputer first defeated the human chess champion, Grandmaster Garry Kasparov, in the late 90s. And that was a humbling and scary situation, to realize that a machine could beat humans at something that humans believed that nobody could beat us at, that we were too smart to be beaten. And soon after that, I remember the experts declaring, well, it's okay. Chess, is maybe easier to simulate than some other games which have many more options, like Go, for example. So these artificial intelligences are smarter than the smartest people. Now, how can that be? Well, I'll get into that a little bit later. How is this useful? Sure, you can play games against things that you can't beat. That's not a lot of fun. However, artificial intelligence-based health diagnosis has progressed to the point where expert systems, on average, outperform general practitioners at diagnosing illnesses. And as I said, these expert machines have always been single task specific. There's been no successful general artificial intelligence developed. There's nothing that you would be able to converse with and, without bumping into the limits of its knowledge effectively. And there is even controversy over how that might be accomplished. How does artificial intelligence work? Well, the most successful approaches that I know of are based on a concept called the neural net approach. And this is a computer system that's designed to act like a network of neurons in the human brain, or in any brain. Scientists have figured out how brains work at this basic level. They're a network of interconnected neurons, and scientists have been able to map networks of neurons in brains and understand a little bit about how they work. So how does it work? Typically, there are a bunch of neuron cells in your brain, and they're heavily interconnected by electrically conductive pathways through which they can send signals to one another. And when a neuron fires, its dendrites, which are the wires connecting it to the other neurons, tickle all of the neurons that it's connected to. And if any particular neuron receives enough tickles from enough dendrites, it fires a signal, and that signal goes down its dendrites to tickle all the neurons it's touching, and the process continues in this sort of a network mesh. Now, how can that create thinking? How can that create intelligence? Well, in a sensing pathway, for example, which is maybe the simplest example we could put forward, the initial neuron is set off by some sort of environmental stimulus, say a chemical interacting with a sensor in the nose, or a photon of light interacting with a sensor cell in the retina, or a touch-sensitive cell on your finger encountering an object, or a temperature sensor in your skin getting hot or cold. As an aside, you've heard of the five senses, right? You have touch, taste, sight, smell, and hearing. Well, we actually have a lot more senses, and this is something that a lot of people don't know about. There's also temperature. You have a sense of orientation. You have a balance sense. You have a sense of time. There's a lot of senses that we have that people don't think about. So whenever someone says, do you have a sixth sense? You can always say yes. Getting back to my example then. So the initial sensor cell fires off a signal when it's excited by an external stimulus. So it fires an electrical signal down its dendrites, relaying the stimulus to a group of neurons that form some sort of a sensory map in your brain. Now, I don't know if that's generally true of all sensing pathways, but it's what I've picked up from reading the odd thing on imaging and how your brain looks at images. And these mapped neurons then stimulate other sets of neurons. They all tickle these neurons that are looking at the map effectively in your brain. And they can detect various patterns, and each group of cells is sensitive to a different type of pattern that may be of importance to the organism. And then these are linked to other areas of the brain that are linked to representations of objects or ideas, and eventually to motor neurons, which allow for a reaction or a physical response to the stimulus. So scientists think that this is how brains process information. There's actually a region in the brain that echoes what the retina sees electrically, and scientists have been able to measure that from outside the brain and can actually figure out what people are looking at or even what they're dreaming about. Now, I don't know exactly how this works, but wow, that's cool. And this is called the visual cortex, I think. Don't quote me because none of this is backed up with references at this point, but this is based on my recollection. So associated with the visual cortex, we have specialized groups of neurons which detect movement or look for patterns. So this is a static picture of the brain, but the brain actually learns and can reconfigure itself in response to novel stimuli or important stimuli. Rewards especially cause the brain to change and learn. If you have some sort of a dopamine hit in the brain locks in what it did to get that. And how does it learn? Well, as far as I know, when the brain receives a reward, it strengthens the connections that have been firing recently. And so the dendritic connections between neurons can grow weaker over time, or they can grow stronger if they are associated with success or what the brain sees as success. So what's this got to do with artificial intelligence? Well, I think the best artificial intelligence simulations are simulating in a computer a version of this neural net in the brain. We've learned from nature, and we can simulate what we think the brain is doing, and it actually works, which is amazing. And it also, of course, gives the scientists some idea that their theories of the brain are correct, right? If you build a simulation of this biological thing and it learns and it can do tasks better than people can do, you've got something. And that's really the coolest part about artificial intelligence, is that we can make minds that are smarter than ourselves at certain tasks. Various layers of artificial neurons are built into the software, and each neuron in each layer is multiply interconnected with each neuron in the previous layer. You put a data input into the first layer, and the strength of the dendrites or connections between each layer is the real gold that makes this thing a unique mind. And how you teach this system to have the right weightings on all these dendrites to respond in some logical fashion to a target is the work involved in the science of artificial intelligence. So using their artificial intelligence magic, these neural nets are trained on a large set of data, and whenever they respond in the desired way, the simulated connections are strengthened. For example, a net can be trained on pictures of a target, and over time it can be trained to successfully pick out that target in any image. And what you need are thousands of different images of the thing that you want to identify. And the system becomes highly trained in this data, but it can also be easily fooled as it has no general knowledge outside of its training to check itself against some sort of pathological failures where it may mistake something that it's never seen before as the thing that it was supposed to detect. Now, some researchers, I believe, just think this is a limit on time. If humans are neural nets in their brains, they take years of training to build up general knowledge. And you can tell this by watching the development of children. They certainly make similar mistakes to neural nets that have been trained on small data sets. Now, I know there's probably scientists trying to develop this general knowledge by just training things as though you'd train a child and have them learn the very simple things and all of the different rules that children learn. But I haven't seen any successes publicized yet, so I don't know how far they've gotten, and I'm hoping to find out over the next few weeks as we interview the experts. So these things seem promising. Specific systems can replace people in specific well-defined tasks that don't require much general knowledge. People have, for years, felt safe from artificial intelligence competition in more complex fields of work. However, as technology continues to improve, artificial intelligence keeps getting better and can do more things that people didn't think it could do. Most of us were very surprised, as I said, when artificial intelligence outperformed the best human chess player. Of course, we know that on specific well-defined tasks, calculating machines are much better and more accurate than people. We know that computers significantly outperform people on these pathological tasks. But it's the general tasks that we thought that we would always be better at. And now it may not be the case. As the field progresses, these systems are getting better. They can detect language, they can respond to our language, they can do all sorts of things. So I've talked a little bit about the background as I understand it. What are the risks? Well, think about what we've done so far. We've created super intelligent systems that are better than people at certain tasks. What will happen when we make a generic or a general super intelligent system? Because these systems aren't just a set of rules, they're trained networks. We don't understand how they work. We know the theory of how they work, but we don't understand the set of rules that govern the intelligence. If we did, then we would be as smart as them. So we're building things that are smarter than us at certain tasks. And they're not working on a set of rules that we define. They're learning themselves. Can we count on the developers to put in the necessary work so that future super intelligent artificial intelligence systems will play nicely with humans? It seems not simple, not straightforward. If you're not giving it a set of specified rules, you're just training it how to do a particular task, and it suddenly becomes smarter than you at that task. It's a little scary. Now, Google, Amazon, a lot of these companies have been experimenting using big data to train big AI systems, feeding them internet discussion forums. Google once let 2 of these AI systems train on the internet to talk to each other and see what they would talk about. And without any constraints on their discussion, they started parroting violent racist memes. That experiment got shut down, but imagine now that you have a general intelligence that's smarter than any human with no rules in terms of how to work with humans and whether or not people should be taken care of or how they should be protected or not. Perhaps these artificial intelligence systems will take no notice of us at all. Maybe they will have other goals, and self-preservation may be top of mind. And I don't know anything about whether people think these systems would be self-aware. That is a much more complex problem than just building an intelligence. A self-aware system has a model of itself and people outside of it, and these models are part of the intelligence. Some people question whether a software program could ever be self-aware. It's just a bunch of bits moving around in a machine. But a lot of people think that self-awareness is just an emergent property of a complex system with models of itself. Just because the brain works in cells rather than on silicon as its electrical basis doesn't make it specially magically different in any way, or at least in any way that science is currently aware of. So something that's an unknown question at this point, I think. What are the other ethical concerns that we might encounter? Well, obviously, if you're aware of popular science fiction, you must be aware of Robocop or the Terminator series, where armed robots turn against humanity. Now, the question in most people's minds who have seen these is, how realistic is this scenario? Is it possible that the artificial intelligences are going to revolt and arm themselves and decide that they want to destroy humanity? Or is this just artistic license of Hollywood? It also raises questions. Military systems are now being designed to perform autonomous decision-making. And a lot of it does parallel some of the plots of say, Terminator. There are requests from the U.S. military to have autonomous decision systems in space because they may be out of contact with the ground. They may have to do things without being commanded. And these systems are weaponized. Extrajudicial drone assassinations are now a matter-of-fact policy for the U.S. They send airplanes, they fly these things from around the world and go blow up their enemies. Now, these systems don't need to have humans in the loop. Many of you are probably using face recognition on your iPhones as security. Imagine armed drone swarms with face recognition programs being set loose in a city with data collected from Google or Apple. You know, Amazon is already experimenting with drone delivery of packages. What's to stop them from adding a handgun to protect the drone and taking contracts? There are obvious ethical concerns here that people should be aware of, and these decisions are being made by the corporations that are at the bleeding edge of this development. These ethical concerns that may be important to us are being made by teams of programmers in Google and Microsoft and Apple. Should we be trusting these people with our lives? Are they the appropriate ones to be making these ethical decisions on the future of human and artificial intelligence interactions? I think there are ethical concerns here that I'd like to explore. There are less obvious ethical concerns as well. Think about autonomous vehicles being developed by Tesla and all of the other automakers. What do you program your automobile to do when it suddenly finds itself in an emergency situation? A child runs out in front of it, or it's got the choice of running over a group of people on the sidewalk or being flattened by a cement truck. Should the car protect its owner, or should it try to protect the most people? What decisions are being programmed into these systems, and who should be responsible for these ethics? I believe these are very important issues that society needs to be talking about now before we release these artificial intelligences in the wild. And if you're a science fiction aficionado like I am, and you've ever read Isaac Asimov's I, Robot series, you've probably struggled with these issues and you've been introduced to these issues. In that series, and is popularized by a movie called I, Robot, the artificial intelligences are programmed with 3 rules. And these rules are to protect humanity and not through inaction to let any harm come to humanity, And then thirdly is to preserve themselves. And I'll leave it as an exercise to the listener to verify whether or not I was correct on that recollection. I apologize if I was not. So the question I would like to understand is, can something like this be programmed into artificial intelligences? Can we require that all artificial intelligences have some sort of rules of robotics like Asimov envisioned in his fiction? Is this even feasible to a system that works on a network that doesn't work by a set of pre-existing rules? How would you go about doing this? And if it's difficult to do, would you somehow count on the people who are developing these systems to incorporate it properly? And then what would be the downsides of not thinking about this question before you invent a general superintelligence that may have very little interest in helping humanity? Another thing to think about, and I remember when this came out in the news a little while ago, Stephen Hawking and Elon Musk both put out warnings or red flags to the public. They had news releases saying that we need to do something now about artificial intelligence. We need to come to an agreement as a species on how we are going to deal with the ethics of artificial intelligence before armed systems are released into cities, for example. This is one of those things that you need to do before the horse is out of the pen. And that's why, although it's not top of mind for everybody, we need to think about this before the crisis and not after. So at this point, I want to summarize. I've described what I understand of the background of artificial intelligence and the applications and where it might be going. And I've described what I think of as some of the risks. And now my hypothesis is that it's difficult to build an artificial intelligence that follows rules because we're modeling these on people's brains. And if you build these brains in such a way that you don't understand how they're doing what they're doing, then it's going to be very difficult to build them in a way that they're going to follow rules as well. It has almost biblical overtones when you think of the biblical creation story about God creating Adam and Eve and having Adam and Eve eating of the tree of knowledge and suddenly having free will and then being cast out of the garden. And perhaps our creation of artificial intelligence will follow a similar path. In effect, you're giving them freedom by creating them. And we need to have this conversation about the ethics and how these things need to be limited before they are set free. And that's why I'm going to be talking to the experts over the next few weeks, and I'm going to try to find out, what do they think? Are they afraid? Thank you for listening to The Rational View, and please tune in again next week. If you're enjoying what you're hearing, please consider visiting my Patreon page and becoming a patron of this podcast at patron.podbean.com/TheRationalView.